All right, we're back with Dr. Gordon Roesler, president of Robots in Space, and we're going to talk about the Space Superhighway, which is an idea that he's been promoting for a couple years now, probably longer if you go back to the space logistics ideas. Gordon, thanks for being here.
I'm always glad to be with you, Jason.
Thanks. Well, let's talk about what the Space Superhighway is as far as concept goes from your perspective.
So think about the large logistics systems on the Earth, shipping lines and railroads and trucks and those sorts of things. They have a lot of features that make them successful. One of them is flexibility. Anything you can throw in a cargo container, you can move anywhere around the world, right? Now think about something like Starship, which SpaceX is working on and promises some, great reductions in cost to get things into space. It's a really large cargo area, but to make maximum use of it, maybe you'd like to take the stuff that's inside of it and move it to other orbits. Not 100 tons in one orbit, but 100 tons that some of which goes here and some of which goes there. Just like, a large ship or something like that. That stuff's all not destined for one port. So, and where do we want to take things? Well, we want to take things from low Earth orbit to GEO, for example, because that GEO is a very high dollar value orbit. We want to take things out to the moon, where we're talking about creating habitats. And maybe we want to bring things back from the moon if resources are harvested there and we want to use them in orbit, not just on the lunar surface. So the Space Superhighway, which is a term, I think first time I'm aware of my using it was 3 years ago in an Aviation Week article, but and that article was called Unlocking Value in Space, Unlocking Value in Earth Orbit. And that's what logistics systems do. If you think about FedEx or UPS or something like that, they allow small businesses to have much larger clientele, right? They unlock value. So this is what we want to do with the Space Superhighway. And obviously it's not a physical road. It's a bunch of, paths in space determined by physics and propulsion systems. But basically something that reaches right now from low Earth orbit to geostationary orbit to lunar orbit, to move things back and forth efficiently and more responsibly.
Okay. So we want to eventually be able to move things, commodities, satellites, who knows what, right? From one orbit to another. And in order to do that, we have to have some infrastructure, right? We've got to move particles. We need some pieces of the puzzle to move around in that. You've identified a couple of elements that are important to the logistics systems: reliability and reusability, and modularity. Let's talk about them for a couple minutes.
So reusability, obviously SpaceX has proved that reusing first stages is an economic win, right? The Starship, they're looking at reusing second stages as well. The upper stage is something that re-enters the Earth and you can turn it around and use it again. Rocket Lab has recently captured a first stage and plans to reuse it. So the idea is catching on. If you have a reusable infrastructure in space, so space tugs, that is the commonly used phrase, you further reduce the energy demands on the launch vehicle. And you reuse a lot of stuff that today we throw away. Most second stages are, if they're not left in orbit, which is a crime, you burn them up in the Earth's atmosphere. And they're expensive. And there's great stuff on them. Whereas if you have a space tug, you're doing the same mission that a space tug is doing, but you're doing it over and over again. To do that, you need lots of gas. You need lots of propellant, right? So the Space Superhighway, the space logistics infrastructure, is going to need fuel depots at various places. And there are studies going on in terms of what propellants and what are the best places to put those depots and that sort of thing. But probably, for any given route, let's say LEO to GEO, you're going to need a depot in both places. You need a depot in LEO and one in GEO as well. One out in cislunar orbit, wherever that, the customers are. because you need the second one to bring the tug back, so you can use it again.
Right.
And the lower the cost to orbit gets, the more practical this becomes. So now we've got tugs, we've got depots, and I'll mention a third useful component of the space superhighway, which is hosting platforms. And there's a lot of different names for these robotic space stations. So these are a place where you can take a box of stuff, sensors, communication systems, or whatever, and plug it in, get power and communications, station keeping, attitude control, and all that sort of thing. So that box didn't have to be part of a completely integrated satellite. It's something that you can. It's very useful for testing things cheaply and quickly. It's useful for doing new science missions much more affordably. At one time, at JPL, just at JPL, there were 70 payloads being developed for Earth observation, and there was not enough money in the budget to fly all of those if you have to integrate them, each one, into a satellite. That's just unaffordable. But if you can take a payload by itself and plug it in and get the same services that a satellite bus would provide. So this is one of the other uses of the space superhighway, is just taking payloads that either need to be tested or can operate on their own, or can be plugged into an existing satellite to upgrade its capabilities. So we have reusability here, and we have reduction of debris, because the more modular your payloads are, the less stuff you leave around, because it's a unique design and that sort of thing. Okay, so that was the reusability part. What was the other part of your question?
Modularity.
Well,
the essence of that, right, as a design philosophy, I guess.
Right. That in a couple of years, the Northrop Grumman's mission robotic vehicle will be launched, and it has the capability to do some limited repairs. For example, if a solar panel or an antenna doesn't deploy properly from a satellite, those robot arms could apply forces that could correct that anomaly. But there are lots of other repairs that it can't do, because satellites aren't designed to be repaired. And a shining example of that is GOES 17. Whose primary instrument is malfunctioning, and it's not providing the data that it would like to, or that the world meteorological community would like it to be able to develop. So NOAA is interested in, are there ways that I can build satellites that I can recover from these kind of anomalies? Right? They're rare, but when they happen, they're have a drastic effect on our understanding of the weather. So adding modularity, things that can be plugged in and removed and replaced and that sort of thing, is of interest to a lot of people. The Defense Department as well. The time it takes to design, build, and fly a DoD satellite, it can be a decade or more. You're worried about obsolescence, right? You're worried about failures. And so this is another place where modularity would come in handy.
Okay. Yeah. And just thinking about the CPUs used inside of satellites right now, they're really old anyway.
Exactly.
Just to start off with. So you think about obsolescence.
You can upgrade them over time.
Right. You pop something new in. Okay. So we've got these reusability and modularity as sort of design philosophy things to be built in. We've got the idea of space tugs and fuel stations and these hubs and adaptable satellites as well. And then regional hubs at LEO, GEO, and cislunar. Okay, this sounds great. It also sounds like an awful lot of stuff, right? What do you think?
Where's the money going to come from?
Yes,
right?
Where does the funding come from? And then also, how much do you need to get a critical mass of activity going? I guess, where it's like, hey, this is worthwhile.
Right. I think one of the earliest customers is going to be the Defense Department to refuel some of their very high value satellites in GEO. They want to be able to add propellant or attach a propellant module to do a number of things. One of them is maneuvering for defensive purposes. Another is maneuvering to optimize coverage. So let's say, I want more satellites over the Ukraine right now. to do that, I have to use propellant, which today limits the life of a satellite. And the third reason is life extension itself. You know, if you have a satellite that's still working, why throw it away? But you have to throw it away if it's running out of gas, right?
Right. Can't keep itself up. Yeah.
Steve Spangler, the former CEO of Intelsat, said this in a forum a couple of years ago. He said, if I have a satellite that's making money, why would I want to throw it away? And so he has the 2 contracts with Northrop Grumman already for life extension of 2 of the Intelsat birds. And so the Defense Department, you know, wants that same kind of capability, and they want it for more reasons. So I think they'll be an initial customer. You know, it sort of sounds like if you build it, they will come. Logistics systems are often built before the customers are there. I mean, look at the interstate highway system, right? That was originally intended primarily for military purposes. And now look at, you know, the economic impact that it's had is really cosmic. But the potential customers for a space logistics network are it's a very broad spectrum of them. For example, think about companies that want to develop lunar resources, right? They want to make propellant, they want to make oxygen, you know, metals on the moon and that sort of thing. If each one of those companies had to develop its own logistics solution, most of them would never happen. I mean, so if we build, I'll call it a national space logistics system, obviously intending to include a lot of, you know, friends and allies and developing nations and that sort of thing, but a national space logistics system that's available for anyone to use it wants to use it, right? So now the lunar resources companies can go, oh, I don't have to worry about that. All I have to do is have some sort of an ascent descent vehicle that can get stuff out to the logistics network, and I'm good, right? Whether that stuff is intended to refuel geosatellites or to build space solar power installations or whatever, they didn't have to solve logistics problem. Similarly, the Defense Department doesn't want to have to solve its own logistics problem for the propellant that it wants. NASA, who wants perhaps to build the next large astrophysics observatory, you know, the successor to James Webb, is seriously considering doing that in a modular fashion, assembling on an orbit from multiple launches. They don't want to have to develop their own logistics solution for that either. So one space logistics system that can service a wide variety of customers, and it'll, you know, it's scalable, right? The first one might be just a single LEO to GEO tug, and with one customer, great. And then a second customer comes along. Maybe it's time to build a depot. Maybe it's time to put another tug up there. So it'll evolve over time, but the potential business cases are so broad, and so many of them that the White House, the Office of Science and Technology Policy, is reviewing this right now, in orbit, servicing, assembly, and manufacture. And that's a wide suite of technologies. And they've asked for public comment on how do we implement our strategy to build these things. You could say, well, there's a lot of different technologies there, so let's invest a little in this and a little in that and that sort of thing. But if the statement was, we're going to start with a large logistics network, that's our goal, everybody can focus. The R&D people can focus, the business community can focus, the policy people can focus. I think this is a real strength of this concept, is to get people to rally around one thing, which has many little parts, but it's one thing that has a tremendously positive business case, tremendously positive national security implications, right? Tremendously positive for the growth of the space economy, for exploitation of the moon. So that's, you know, that's the vision.
And also, yeah, building the system first before an opponent can. Okay, so you can start small. And I think I really like the idea of not having to have a complete satellite made specifically for this one application, right? Allowing people to launch more stuff sooner and cheaper, right?
Now I'll put in a plug for you.
Yeah. All right.
Building the technologies, most of the technologies to do this are in hand.
Mhm.
And we have interfaces that are already in space being tested on the space station.
Mm.
We have robotic arms that we know work
Mhm.
in space. We have transport vehicles and communications. What don't we have yet is the business processes.
Mhm.
How long in advance do I have to sign up for a ride before I
Mhm.
can send my module up there? How does this all interface with the launch architecture? What are my contractual requirements? What do I have to do for insurance? What are the insurance implications of all this? So there's this wide variety of questions that any potential customer is going to have. And what you really don't want is you don't want every possible provider of space logistics services to come up with their own answers, right? We should develop some business processes that are common to this logistics network, just like in the shipping industry, right? What you can go and find out what the rules are to put stuff in a container. What's the maximum weight? Can I have flammable stuff in there? Whatever. And everybody accepts all that. And that's where we need to go for the space logistics network, the Space Superhighway.
Okay. Cold Star might have some expertise in that area.
Yes.
All right. So we've already, as you pointed out, have some companies and technologies in that are ready to just be put together on this stuff. We know we've got the space tugs, right? We've got the I was talking to Trevor Blake. We've got the fuel stations, right? Those ideas there. That's been around for a while. Satellites. The hubs are interesting. Would Tethers Unlimited be something that would be suitable
So
for that?
there are several companies that are working on this idea. Tethers is one.
Okay.
Arcasys is
Mm.
another, and a newly announced one with Steve Jurczyk and Ben Reed heading
Okay.
it, called Quantum Space.
Hmm.
They're all looking at uncrewed platforms where
Hmm.
things can be brought and robots can install parts and that sort of thing.
Hmm. Okay. And they're going to need sensors and monitors and measurement devices, all kinds of things. That's exciting. So what is needed here? What kind of a spark do we need, I guess, to get things started?
So 20 years ago, when I started working in
Yeah.
space robotics, I really felt like a voice in the wilderness.
Hmm.
The typical answers were, the technology is too hard. There's no business case. This isn't the way we do things. And now a strategy for implementing it is being developed at the White House, right?
Mhm.
So, okay.
That's as square as it gets, right? Yeah.
So if I was to say to the White House, what do I think you should do? First of all, I think you should take your general strategy on in-space servicing, assembly, and manufacture and focus it on this logistics problem, because this is where the business case really is. And what would I suggest that the agencies, the Department of Defense,
Mhm.
NASA, NOAA, Commerce, what would I suggest that they do? I would suggest that they provide seed funding first for designs and architecture concepts, and then for prototype tugs and that sort of thing. But not a government, the concept should not be a government owned network. It should be a commercial network, because most of the customers are commercial. But with government interest. So government provides seed funding and government says, we will be a customer. We will use this, right? We want it. Here are the things we want it for.
Yeah.
And because these are the things we want it for, you, the developers, have to make sure you address those if you want our business, right? This is what was done with the COTS program back in the 2000s, the Commercial Orbital Transportation Services program that resulted in the Falcon 9 and the Antares launch vehicles. Government spent $500 million. We got 2 entirely new launch vehicles. I don't know how much private investment went in there, but it was way more than $500 million. Right? And the government isn't as good at developing things as industry is. Right? So these are the two. And I guess, okay, so seed funding, being a committed customer, and continuing with the R&D expenses, the R&D programs that are already going on in the government, because a lot of those are more advanced than what's going on in industry. The robot arms, a lot of the robotics work was done at the Naval Research Lab. Some's being done at the Air Force Research Lab, and that kind of stuff needs to continue to help industry to, you know, just to then port this technology to the industry once it's developed. So those are the three things that I think we need. There isn't much question about the business case. That's not
anymore.
just
Right.
just a little activation energy provided by seed funding. Let's say 20% of what you think the cost of a given mission is going to be. The government says, and it's competitive, right? Say, who wants to build this tug? Who wants to build this fuel depot? Here, you know, send your proposals in. Here's what we're going to put out in terms of seed funding. It worked great for COTS. It's working great with the Commercial Lunar Payload Services Program, the CLPS program. It's a good model.
Okay. Does this program, this idea need a champion? Does it need a quarterback?
Well, I think, you know, I think that quarterback is the Office of Science and Technology Policy,
Okay.
Which works very closely with the National Space Council.
Mm-hmm.
Right? Chirag Parikh at the Space Council is, you know, on board with these kind of activities, and so I think, you know, the vice president has really started to take an interest in space. I thought her declaration about no use of kinetic anti-satellite weapons was bold and well informed. So these are kind of things that eventually will, you know, rise to her level. I think everyone that has any interest in this area should make an input to OSTP, you know, from their request for comments that they just put out. Everyone should say, if I had my say, this is the way it would be developed.
Okay.
I'm planning on writing a couple of those myself. So.
Right. Yeah, I'd love to have you back on in like 6 weeks to talk about what you discover and what you comment on.
Yeah.
Yeah. Okay. So I'll link to that in the description, and people can go there, because that was going to be my final question. Was, you say you want to be involved, what should you do? Who should you talk to? Well, give your input on this thing. Okay. Well, I appreciate that.
One more thing about champions. I believe that there should be a national office for this space superhighway. I think, you know, a lot of people say, oh, one more government office because it's got to coordinate across NASA and DOD and NOAA and Commerce and whoever, plus commercial industry. I really think there needs to be a single focal point. You know, OSTP has a lot of stuff to do, so they're going to champion starting of this thing, but having an office that organizes it, you know, is an honest broker between potential performers. I think it's a path to success would be to create an office like that.
Okay. All right. Well, thanks for doing this, Gordon. Appreciate it.
See you, Jason. Thanks. It's always a pleasure talking to you. You have great questions.
You bet.